All right, so today we are talking about surface area of rectangular prisms. Later we'll do triangular prisms. But today we're going to focus hopefully first on surface area of rectangular prisms. So the first thing we need to know is, what is surface area? I like to think of it in a couple different ways, so I'll use a couple different examples. The first example I think of is you and your skin. Your skin is the area that is the surface of you, right? So for example, if it is cold outside, you do everything you can to cover up all your surfaces, right? If your hands are cold, you put on mittens. If your head's cold, you put on a cap or a beanie. You wear long pants to cover up more of your legs, right? Your skin is like your surface area. Another good example I like to use is wrapping paper. And think about it this way, right? Let's say you went Christmas morning and you went down, and underneath your tree there was a present for you. But let's say someone only wrapped part of it, like they didn't wrap the whole thing. Well, it's kind of pointless, right? Like, it's either part of the fun is unwrapping the present and seeing what it is, but if you can just see what it is without wrapping it, then what's the point? So when we think about surface area, we have to think about the area of the entire surface of the shape. In this case, a rectangular prism. And we're going to be able to add all those things up and try to find that entire area. Basically, think of it, how much wrapping paper do you need to cover up the entire shape? So let's go ahead and jump into it with rectangular prisms, and eventually we'll get to triangular prisms, and the next day we'll do pyramids as well. So let's start with rectangular prisms, okay? So let's start by first drawing a rectangular prism. If you're still having trouble with that, that's okay. It takes a little bit of practice. I'll start by drawing kind of a taller one here. So I'm going to start with a rectangle. Now you could draw the second rectangle with the dotted lines, or this is another way you could do it. So this is another way that could work. Is from each corner you're going to draw a slanted line, and that slanted line should be the same distance and the same angle as all the other lines, and one of them will be dotted here. Okay. The closer those lines are to like kind of clones of each other, the better the shape will look. And then I'll just connect these dots here, the ends. All right, so we got ourselves a nice rectangular prism, hopefully. And I'm going to put some lengths on here. So I'm going to call this one 5 inches. I'm going to call this 4 inches. And let's make this one 10 inches, just kind of easy like that. Okay, so in order to find the surface area in total, what I'm going to do is I'm going to find the surface area of each piece and then add it all together. Now, there's lots of different ways to do this. There's lots of different little shortcuts to take depending on how you understand the picture and everything. So we'll break it down. We'll take it nice and slow at first, and then I'll show you some shortcuts that you could use. Okay, so first, let's start with the top and the bottom. Now, on a shape that's a rectangular prism, we should know that a rectangular prism or a cube, same thing, or in terms of amount of sides, there are a total of 6 sides, right? So we need to find the area of the 6 different sides, and then we'll be able to add them all together and get what we need. So the first side I see, I'm going to highlight this here, is this base, this bottom part. Okay. So this bottom part we can see is a rectangle that is 5 by 4. Right? It's 5 by 4. And not only is it 5 by 4, but there's not only there one of them, but there's also this second one here at the top. So there's two. There's 2 rectangles that are 5 by 4. one on the bottom, and one on the top. You guys all see that? Okay, so remember, find the area of a rectangle. All you have to do is multiply those sides. Okay. So this is going to be 5 times 4, which is 20. And this is 5 times 4, which is also 20. Now, again, you might be able to find shortcuts here. Like, for example, you said, Mr. Leon, can I just multiply 20 by 2? Yeah, you could do that. That would also work. Okay, next, let's do one of these other sides. All right, so let me get this red part out of the way. How about this side right here? Okay, that is a good example. This is another rectangle, and this one is a little bit taller. This is a 4 by 10. And again, there's not just one of those. On the flip side, there's a second one over here. Hopefully you guys see that there's two. And if you're having trouble seeing this, then you can definitely label them. You can label, when I say label them, I mean you can put like a 4 here and a 10 here. More 4s and 10s so you can see, oh, that's a 4 by 10. I get it now. All right, and then lastly, all right, so let's multiply these, sorry. So 4 times 10 is 40, and 4 times 10 is 40. All right, and then lastly, we've got the one more side, which is a little bit harder to but we have this basically this this front side and the back side. So it's going to be this part right here, front, and then also the back. You can I'll kind of like outline it here. You can kind of see that. Okay, so that one is 5 by 10, right? Because again, this is the 10 right here. So we've got another big one that's like here. And there's two of them. Yeah. Right? And we know that 5 by 10, 5 by 10 here. Sorry, be consistent. All right, we know 5 by 10 is 50. Right? Okay, so what do we do? Let's just add up all those sides, right? All the things we have. 20 plus 20, 40 plus 40, 50 plus 50, right? 20 plus 20 plus 40 plus 40 plus 50 plus 50. Go ahead and add all those up, right? You use your calculator if you want. Or you can just say, okay, 50 plus 50 is 100, 180, 200, 220 inches squared. We're talking about area, so it's going to be inches squared. Okay, so does that kind of make sense? Hopefully. Now, you might see some shortcuts, right? You might say, well, Mr. Leong, I just did 3 of them together, 20 plus 40 plus 50, and then multiplied it by 2. That's totally fine. Mr. Leong, I only found one box, and then I multiplied each by 2, and then I added those together. That's totally fine. As long as you get all 6 sides and kind of whichever way you're going to figure that out, you're going to be fine, okay? So that's how we find the surface area of a rectangular prism. You take all of them, and then you take all 6 sides, and then you just add them together. All right, so let's try one. Let's have you guys try one here on your own. Let's do a rectangular prism that's a little bit flatter. A little bit longer. Let's say this is 6 centimeters. Say this is 6 centimeters. And we'll say this is 12 centimeters. Okay. Now, I didn't even draw the back part. Maybe this will make things easier, a little simplified when you only see 3 sides of it. So why don't you go ahead, try and figure out what the surface area of this shape might be. Let me show you a little bit more of this other example so you can kind of see it. No, maybe not as much. All right. Go ahead and put in the chat once you think you've got it. All right, anyone take a guess? Okay, thank you, Nee. All right. Okay, so remember there are 6 total sides here. 6 total sides. So let's start with the one out in front. This one right here. So I'm going to do this a little bit differently here. I'm going to say, you know what? I'm just going to find 3 of the sides. I'm going to just double it. Okay, so first one I have is that 6 by 6 right there. Okay. And I know that 6 times 6 is 36. Okay. Next, I've got and this will be in yellow here so you can see it. Next, I've got this other one here. I'll put it in red. That is 12 here and 6 high, so that's a 6 by 12. So 6 by 12 is equal to 72. And again, we will put this in here. And then lastly, we've got this other shape up here, which is, again, this one's also 6 by 12, right? Because this is 12 right here on the side and 6 on the bottom. So this last one is 12 by 6. Oops. Now, I can either add those all up right now and then double it, or I can double each one. So remember, on the yellow side, there's 2. There's a front and a back. So I'm going to say times 2, which is going to be 72. There's a right and a left, the red ones. So that's times 2. So that's going to give me 144. And this blue one, there's a top and there's a bottom. So I'm going to multiply that by 2, and I'm going to get 144 as well. So let's add up all those. 144 plus 144 plus 72, and I should get 360 centimeters cubed or squared. Right, does that make sense? All you're trying to do is find the different sides, and then you're going to add up all the sides. Okay? Add up all the sides. Now, there's a different way you can look at these problems, right? And I'll show you one more way, and this is kind of like a shortcut, and this is a formula that you could use, okay? The formula is this. And this actually works for all prisms. The formula is the surface area, SA, is equal to 2b, capital B, plus P times H. And I'll explain what all those letters mean in just a second. And this is more advanced, so only if you'd rather just do all the separate boxes, just keep doing that. Okay, and what do these mean? Big B stands for base area. P stands for perimeter of base. And H stands for height of whole shape. What is this formula? I'm going to show you what it is. We're not going to spend too much time on it. This is just, some people like this because it kind of is a shortcut if you know formulas really well. I recommend most of you still do it the way that we just did it here with the yellow, red, and pink, blue, where you find all the sides and just add them together. That just kind of keeps it really simple. But let's take this. This shape right here. And if you think about it, when you look at a rectangular prism, you have to think about what happens when you unfold it. That's what surface area is. When you unfold it into 6 separate rectangles, okay, squares and rectangles, okay, that's what you end up getting. You get a shape that's unfolded, and it'll look like this. So imagine this shape right here, but we're going to unfold it. Okay, so I'm going to unfold it, and it's going to look like this. Can everyone see how that is this shape right here just unfolded, right? So the yellow part is this yellow part right here, 6 by 6. And then what I did was I just kind of unfolded it. It's like I broke it apart. It's like you took a box apart, and that's what you see. And so I'm going to label this right here. This is 6 by 6. And then this is 12. There's your numbers right there. Okay, so you can, if you think about this is what we call a net of a shape. A shape that is unfolded is the net of the shape. So here's a shortcut that we could do. First of all, we said big B is base area. Well, I'm going to call the base area that 6 by 6. I know it's not really what it's sitting on, but we're going to say 6 by 6. So this area right here is, I'm going to call this my big B. Now notice 6 times 6, which is 36, so I get 36 on both. Okay, so I've got two of them, right? So that's why it's called 2B, two bases. So 2 bases plus perimeter times height. 2 bases, which is 36. So 2 times 6, 36 is 72. So we know that. Okay. Now, one thing you'll notice is you could look at this as 4 separate rectangles, the ones in the middle, or watch this. You could think of it as one big rectangle, right? It's kind of like if you were to take a water bottle and you were to cut it up and down, you'd end up with actually a rectangle once you kind of unfold it out. So what you're doing here is you're taking this rectangular prism and you're going to cut it open so that it's just one big rectangle in the middle. Now, how tall is that rectangle? It's 12. And how long is that rectangle? Well, think about it. Let me put the lines back here. This is 6, and it wraps around. So this is 6, that's 6, and this is 6. But instead of saying 6, 6, 6, 6 over and over, why don't we just call that the perimeter of the base? Okay, the perimeter of the base shape. So 6 plus 6 plus 6 plus 6, this is 24. And again, this is a little bit confusing, so I'm not expecting all of you guys to use this. I would suggest only a few use it, actually. And the height of the whole shape is 12. So again, where did I get that 24 from? Because instead of going 6 plus 6 plus 6 plus 6, I said, no, let's just add them all together and make 24. All right, so we do 12 times 24 in our calculator. And you get 288. And then you add that to the 72, and you end up with your 360. If this doesn't quite make sense to you, that's okay. Don't fret about this one. This is a little bit more difficult to understand, but it's one of those things where if you take the time and you understand it, then you can actually get it done pretty quick because it's just a formula. Again, the key is the base, 2 base areas. So you have the top and the bottom, and then when you unfold it, the middle section actually makes one big rectangle. Right? It makes one big rectangle. It's that you can do all in one shot. But for now, if this is a little bit confusing, okay, I want you to focus more on doing it this way. Splitting it up into the separate pieces and then multiplying to get what you need, okay? And then, again, you could do it like that. You could break it down like this instead, where you have you draw out all six shapes. That works for you too. Or, there's kind of a lot of different ways. Some people like to do just 3 of them and then double it. There's a lot of different ways that you can kind of do and operate these problems. Again, what you want to do is make sure that you account for all 6 of the sides. And when you add up all 6 together, then that is that's what the surface area is. That's what it is, right? Yeah, so this one right here is a rectangular prism, but unfolded. So yeah, if you don't quite understand the unfolding and the formula part, then it's a little bit confusing. Then don't worry about it. Just worry about doing it by the sides. Okay, this is just kind of a sort of advanced shortcut. What this does, this formula, is it helps you for all prisms. It makes it so every prism is a little bit easier to do, regardless if it's a rectangle, triangle, whatever. And we'll play around with this a little bit with the triangular prism. Okay.